For number one, it says find the first 5 terms in the sequence. So it just gives you the formula. Remember, a sub n means we can find any term in the sequence. So we want to find a sub 1, a sub 2, 3, 4, and a sub 5. So you just plug in n equals 1. 1 squared plus 2 times 1 is 3. Plug in a 2. 2 squared plus 2 times 2 is 8. If you plug in 3, you get 15. If you plug in 4 into that formula, you get 24. If you plug in 5 into that formula, you get 35. So you found the first 5 terms. That's the same for the number 2, so I'm not going to do one just like that. Let's move on to number 3. It says find the 7th term of each sequence. So first of all, we've got to determine, can we do this with a formula? If not, we're going to have to do it the long way. So if there's a common difference or common ratio, we know it's arithmetic or geometric. But if you look at number 3, or the first example here, we see that we subtracted 1, then we subtracted 2, then we subtracted 3. It's not the same amount. So we actually cannot treat this as arithmetic. We're going to have to just do this the long way. So we have a sub 1, a sub 2, a sub 3. So the pattern will continue. So the next time we'll be subtracting 4. So let's write it out. So next thing we'll do is subtract 4. 4 minus 4 is 0. The next thing we'll do is subtract 5. 0 minus 5 is negative 5. Here's a sub 4. Here's a sub 5. And then we'll be subtracting 6 from that. I got to write down here. Negative 5 minus 6 is negative 11, and that would be a sub 6. And then we'll be subtracting 7, it looks like. What the? Find the 7th term. A sub 1, 2. Oh, I skipped this. This is a sub 3. This was a sub 4, 5, 6. So this was a sub, this was a sub 3, 4, 5, 6. So this was a sub 7. Negative 11 would be our answer. So we just kind of had to do it the long way. That would be the only way we would be able to do it if it's not arithmetic or geometric. So with this one though, this divided by this is 2. 8 divided by 4 is 2. 4 divided by 2 is 2. There's a common ratio. Therefore, it's geometric. So our formula a sub n is equal to a sub 1 times by r raised to the n minus 1 allows us to find any term in the sequence. A sub n is equal to a sub 1 is 2. Our ratio is positive 2 raised to the n minus 1. It wants us to find the 7th term, a sub 7. So we have 2 times by 2 raised to the 7 minus 1. We type it into our calculator and we would get 128. That would be our 7th term. Determine whether the sequence is arithmetic. If so, identify the common difference. So we would look and see, is there a common difference? Are we adding and subtracting the same amount each time? So let's look here. 31 minus 25 is 6. 25 minus 19 is 6. 19 minus 13 is 6. So we're adding 6 each time. Yep, looks good. So we'd say yes. And our common difference, the common difference was equal to 6, positive 6. So let's look at this one. This one, let's see if we're subtracting the same amount each time. So if I look here, I see 36 minus 24 is 12, and then 24 minus 16 is 8. So we added 8, then we added 12. That's not going to work. And if you do 54 divided by 36, 36 divided by 24, it's not the same thing as 24 divided by, it's not a common ratio either. So therefore, it is, but it didn't even ask us that. It asked us if it was arithmetic. So we would say no. And why? There's not a common difference. Okay, so right here it says, on the test, it's going to say, if it is arithmetic, then write an explicit formula. So with number 5 right here, we can write an explicit formula. So you'd have to remember this formula. For arithmetic, it's a sub 1 plus n minus 1 times by the common difference. Let's plug in what we know. A sub n is equal to a sub 1 was 13, plus we're leaving it general, n minus 1 times by 6. We would then distribute the 6 in. So we would have a 13 plus 6n minus 6. So then our final answer would be, the explicit formula would have been 6n, and then 13 minus 6 is 7. So then 6n and then plus 7. That would be on the test. It would say, if it is, write an explicit formula. So you have to recognize, because it's arithmetic, it was that formula right there. Okay, it says find the missing term of the arithmetic sequence. So because it's arithmetic, we know there's a common difference. Now remember, I did show you 2 ways to solve this. So you could solve directly for x here. So you could do it by setting up a true statement. It's true to say this minus this will equal this minus this. So 24 minus x equals x minus 4. And you'll just solve for x. So you'll add x to both sides. So you have 24 equals 2x minus 4. You'll add 4 to both sides. 28 equals 2x. Therefore, x equals 14. That was solving directly for that value. So we would find that that's 14. So, however, if we were given something like this, where we are missing multiple things, we can't solve that way because we can't put an x here and an x here because they're not the same value. So instead, you'd have to set up a true statement. Because we're told it's arithmetic, our true statement would be 4 plus something equals that, plus something again equals that, plus something again equals 13. One trick people have noticed is the number of commas is the number of question marks. Because it's arithmetic, it's plus. If it was geometric, we would have times signs here, but it's plus because it's arithmetic. So now we have 4, and then we have plus 3 question marks equals 13. So then we would subtract 4. So we have 3 question mark equals 9. So then question mark equals 3. So now remember, that just tells you what you were adding each time. That was your common difference. So we were adding 3. So 4 plus 3 is 7, plus 3 is 10, and then you'll end up right, plus 3 is 13. All right, so you will most likely be given one of this caliber. They won't give you that part though. So one like this and one like this. Explain what it means for a formula to be an explicit formula. It allows you to find any term in a sequence. And it's nice because you don't need to know the previous term. So that would be good enough. It allows you to find any term in the sequence, or it's in terms of n. So it's written with an n. It's written in terms of n. And it allows you to find any term in the sequence. So it says write an explicit formula for this. So you've got to say, well, our explicit formulas can be arithmetic or geometric. So let's see which one it is. 16 divided by 8 is 2, 8 divided by 4 is 2, 4 divided by 2 is 2, making it geometric. Explicit formula for geometric, you need to have memorized a sub 1 times by r raised to the n minus 1. So we would say a sub n is equal to a sub 1, 2, our r was 2, raised to the n minus 1. There's our explicit formula. So now looking at this one, there's a common difference. This minus this is 2, this minus this is 2, this minus this is 2. It's arithmetic. So our explicit formula, because this example was arithmetic, would be a sub 1 plus n minus 1 times d. Plug in what you know. A sub n is equal to a sub 1 was 2 plus n minus 1 times by 2. Distribute 2 in. So we would have 2 plus 2n minus 2. So our formula here would be a sub n is equal to 2n. So there's our explicit formula for arithmetic. So make sure you have them memorized for both geometric and arithmetic for the test. That allows you to find any term in the sequence. That is not the sum. That just allows you to find the 12th term, not the sum of the 12 terms. There is a difference, so make sure you understand that. It says find the 8th term of each geometric sequence on number 11. So we want the 8th term. And you're going to want to use a formula. So this divided by this is 2. This divided by this is 2. It's geometric. A sub n is equal to a sub 1 times by r raised to the n minus 1. Plug in everything you know. We want a sub n to be equal to our a sub 1 is 4. We're timesing by 2 raised to the n minus 1. It asks us to find the 8th term, so just plug in a sub 8. 4 times 2 raised to the 8 minus 1. You type it into your calculator. It's that simple. And we get number 11, just I'm looking at my key here, 512. The 8th term, not the sum of the 8 terms, just the 8th term was that. So looking at this next one, it always gets people for some reason, but you just gotta not get confused by the little weird colons. So this divided by this is 0.25. This divided by this is 0.25, making it geometric. So a sub n is equal to a sub 1 times by r raised to the n minus 1. Plug in what you know. A sub n is equal to a sub 1 is 20,480. Our r is 0.25, or 1/4 raised to the n minus 1. It does ask us to find the 8th term. So a sub 8 is equal to 20,480 times by 0.25 raised to the 8 minus 1. You would type that into your calculator and you get 5/4. If you got a decimal, you would just hit math, enter, enter, as we well know. This is number 12. Write each series using summation notation, then evaluate the finite series for the specific number of terms. That is worded very similar, if not exactly, to the test. So it wants us, now we're noticing that because of the plus signs, we're now switching to sum. So this says find the sum, so we're writing it in summation notation, and we're told we're summing it up for 8 terms right here. So we know it's finite. So n equals 1 to 8. That's the number of terms we're summing up. Now right here goes our formula. Is it arithmetic or geometric? So this divided by this is 3. This divided by this is 3, making it geometric. The formula for geometric, a sub 1 times by r raised to the n minus 1. Our a sub 1 is 1 times by our r, which is 3, and then n minus 1. So that's how we write it in summation notation. We could just type it into our calculator and we would get 3280. All right, so right here, let's see, we are summing for, it looks like 12 terms, n equals 1 through 12, and then we got to see if it's arithmetic or geometric. So it looks like it's not geometric, it's arithmetic. 39 minus 32 is 7. 32 minus 25 is 7. So we would say our explicit formula is a sub 1 plus n minus 1 times b. So our a sub 1 is 25 plus n minus 1. Our common difference was 7. You would take the 7 in. So that would be 7n minus 7, 25 plus 7n minus 7. So then we would have 7n plus 18, because 25 minus 7 is 18. And then you could just type it into your calculator, and if you do, you get 762. That would be the sum. It says evaluate each series. So the first thing I want you to recognize is this is infinite. If it's infinite, we have to make sure it's not arithmetic. Arithmetic infinite, we can't find the sum. But it's not. It's geometric. How do I know? Because look at the formula here. It's a sub 1. Sorry, I should have wrote below it. A sub 1 times r raised to the n minus 1. Our a sub 1 is a 1. A sub 1 is 1. Our r is negative a half. So you have to ask yourself, it's infinite, it's geometric, and sometimes we can find the sum. Only sometimes. So remember, if your r value, not including the negative, is less than 1, then it's getting smaller and smaller till it approaches 0, making us able to find a sum. So 1/2 is less than 1, so we can find the sum. Now, this is a word you're going to see on the test. It converges. So it converges to a sum. So if you can find a sum, it converges, and we have to use the formula s is equal to a sub 1 over 1 minus r. Another formula we have to have memorized. Our a sub 1 was 1, so our s is our sum. Our sum is equal to 1 divided by 1 minus negative a half. Now, keep in mind when you do plug it into the formula, you do actually use if it's positive or negative in the formula. So then that makes it 1 divided by 1 plus a half is 3/2. So if you do that, dividing fractions is easy as pie. Flip the second fraction and multiply. Our answer is 2/3. Our sum actually does come out to be 2/3. Now this one, notice it says evaluate the series. This one is finite, because look, we know a sub 1 is this. We know this is a sub 2, a sub 3, and then we have some a sub n. So we're going to write this in summation notation. So we have the sum. We would write our formula in here. It's geometric. This divided by this divided by this, 4o. Uh-oh, did I write something wrong? Oh, no, we're not. I'm doing good. So we're doing good. So we have 16 divided by -4, which is -4. -4 divided by 1 is -4. So we're timesing by -4 each time. So our explicit formula is a sub 1 times by r raised to the n minus 1. Our a sub 1 is 1, and then we are timesing by -4 raised to the n minus 1. And then we're summing up 1 through we don't know. So we're going to have to hurry and figure out how many terms we're summing up here. So we kind of would have to do this with a logarithm if you remember, and it might not hit you that that's what it is. But you're going to go back to this formula and plug in everything you know. We know a sub n is -16384. That's equal to a sub 1 times by -4 raised to the n minus 1. And now we'll solve for n. So we would divide both sides by 1. That doesn't change anything. -16384 equals -4 raised to the n minus 1. We're going to make this positive because both sides are technically divided by we can divide both sides. Oh my gosh, you scared me so bad. Oh, sorry about that. A student just scared me. Anyways, back to the video. Yep, see, divided by -1. So then we would get 16384 equals 4 raised to the n minus 1. Now you can't divide by 4, so we would log base 4 both sides. Log base 4, log base 4. So then now that cancels out. Now remember, we have log the base 4 of all that stuff. So we have to use the change of base formula. Log of 16384 divided by log of 4. And that's equal to n minus 1. So now if you type this into your calculator, this divided by this, you actually get 7, I believe. 7 is equal to n minus 1. And you add 1 to both sides, therefore 8 equals n. So we had to do all that so that we could figure out that this was a sub 8, so that we can then put an 8 up here. So now we know we're summing up 8 terms. Now let's say you were desperate and you were like not sure if you could remember this. Couldn't you just take the time and literally, since you know you're timesing by -4, times by -4, clear out, and then count to see how many terms it took? Just saying. Just saying. Okay, now it says right here, determine if the infinite geometric series converges or diverges. This is a test hint. If it converges, then evaluate the sum. So remember, if sum infinite, how do we know it's infinite? I'm going to point out the ... means it's infinite, and we aren't told how many terms are there. So that makes it infinite. Now remember, if it's geometric and infinite, if it's getting smaller and smaller, we can find the sum. If it's getting larger and larger, we can't find a sum because it's going to get so large and never stop, and we would be adding forever. If you look at this example, 30 plus 36 plus 43.2 plus 51.84, it's getting larger and larger. So in this example, we would say, well, we're timesing by, and you could say, well, it's getting larger and larger, so it's not getting smaller and smaller. It's never going to approach 0, so we would not be able to find the sum. There's no sum. It diverges. Now, another way is to check, does this divided by this divided by this divided by this, what number is that? So if you do that, you're going to see it's 1.2. 1.2 is greater than 1, so therefore it diverges, and you can't find the sum. So looking at this one, I see we're getting smaller and smaller. Look, -2, 1, a half, a fourth, it's going down. So, or you could just check this divided by this. So that divided by that is -1/2. This divided by this is -1/2. This divided by this is -1/2. So if we're timesing by -1/2. Now you don't look at the negative, but isn't a half less than 1? Yes, so it's converging towards a sum, because as we keep going, it's eventually going to be 0. Therefore, we can actually find the sum. But it's infinite, so you have to use the formula S is equal to a sub 1 over 1 minus r. Our a sub 1 is -2, and then on bottom we have 1 minus our r is -1/2. So that means we have -2 divided by 1 minus -1/2 is 3/2. So then you could type it into your calculator, but you would need parentheses around that. So we have -2 divided by 1 divided by 3/2. I write it like this to help me do it by hand. Dividing fractions is easy as pi, flip the second, and multiply. So that means we get -4/3. Our sum is -4/3. That was just an example kind of similar to the test, okay? If you can find the sum, it converges, and you can find the sum, and there it was. If you can't, there's no sum, it diverges. Okay, number 17, write a recursive definition for each sequence. So you would say, okay, recursive is the one that we'd never even use, but it's easy to write. It's in terms of the previous term. So this divided by this is a half. This divided by this is a half. So we're timesing each previous term. We're taking the previous term, timesing it by a half to get here. Previous term times by a half to get here. So remember, this is how we write it. A sub n is equal to a sub n minus 1. We have the previous term, and we're timesing it by a half. So if I was to give you a formula on the test, and I said, given a sub n is equal to a sub n minus 1 plus 2, where a sub 1, oh yeah, and then right here we would also say where a sub 1 is equal to 80, because you have to say, starting with 80, and we're taking the previous term and timesing by a half. So this would be our answer. Sneezing. Okay. So I might say on the test, given this formula here, where a sub 1 is 10, given this formula, write an explicit definition. So if I did that, you would take this information, you'd say, okay, so we're starting with 10, and we're taking the previous term and adding 2. So the next one would be 10 plus 2, which is 12. Then add previous term, add 2 is 14. Write out a few, and then you'd recognize, oh, for example, this one is arithmetic, and so now you could write an explicit formula, a sub 1 plus n minus 1 times by d. So our explicit formula for this recursive formula would be a sub 1 is 10 plus n minus 1. Our common difference was 2, distribute 2 in. So a sub n is equal to 2n, and then 10 minus 2 is 8. So just keep in mind that we might say, given this formula, write a explicit formula, which is the one that we use all the time. So if that's the case, write out what you're seeing. You take starting with 10, you take the previous term, add 2, write it out, and then write your formula. Okay, write a recursive definition for each sequence. So if you look at this one, we have a common ratio. Divide that by that, you get 7. That divided by that is 7. That divided by that is 7. So our a sub n would be equal to we take the previous term, and we times it by 7. And then we would have to say we're starting with a sub 1 is 3. So once again, on the test, we might go backwards. So that would be our answer, but we might go backwards on the test and say, given a sub n is equal to a sub n minus 1 times by 5, and a sub 1 is 2, write a explicit formula. So this would be a recursive formula. So you'd say, okay, I'm taking the previous term and timesing it by 5, and I'm starting with a 2. So 2, the previous term times 5 is 10. Previous term times 5 is 50. So now I have some written out, and now I could write a formula. This divided by this is 5. This divided by this is 5. So now I could write an explicit formula. A sub n is equal to a sub 1 times by r raised to the n minus 1. Just if it asked you to take a recursive definition and translate it into an explicit. So then you'd say, well, a sub n is equal to a sub 1 was 2. It looks like we were timesing by 5 raised to the n minus 1. Okay, number 18, it says find the 18th term of each arithmetic sequence. So you would have to recognize on number 18 that this is arithmetic and it has a common difference. This minus this is 4. This minus this is 4. This minus this is 4. So you'd say an arithmetic sequence general formula is a sub 1 times n minus 1 times d. So a sub n is equal to a sub 1 is 5 plus n minus 1. Our common difference is 4. We could just practice simplifying it. So we have 4n, and then 5 minus 4 is 1. And now it says find the 18th term. A sub 18 is equal to 4 times 18 plus 1. Our 18th term here would be 73. Use the arithmetic mean to find the missing term in each arithmetic sequence. So we're told it's arithmetic. So once again, our true statement, because it's arithmetic, is 28 minus x will be equal to x minus 6. This minus this equals this minus this. That's how it works. We know that. So you'd add x. 28 equals 2x minus 6. You'd add 6. So then you have 34 is equal to, you added 6 over, equal to 2x, divide by 2. So this was solving directly for that value in the middle. So x is equal to 34 divided by 2 is 17. And then we do the same thing here. Because we're told it's arithmetic, it's our true statement to do this minus this equals this minus this. If it was geometric, it would be different. It would be this divided by this equals this divided by this. So just keep that in mind. Geometric looks different. I probably should do an example like that next. So negative 14 minus x equals x minus 2. So we'd add x. So we have negative 14 equals 2x minus 2. You'd add 2 over. So that's negative 12 equals 2x divided by 2. So x equals negative 6. But with geometric, we've got to remember that it is different. So let's do an example of geometric. 2 blank 16. I don't know, I'm just making it up as I go. So if I told you it was geometric, you'd say, okay, let's call this x. And you would do 16 divided by x equals x divided by 2. This divided by this equals this divided by this equals this divided by, you get the picture. With geometric, it's division. 16 divided by x equals x divided by 2. Those x's should be across from each other. So then you'd multiply up. 16 times 2 is 32 is equal to x times x is x squared, and then you'd square root both sides. This example I made up didn't come out to be a whole number, a pretty number, but it should on the test if that's asked. But don't forget, when doing this, I already forgot to write something. Really, we don't know. It could be plus or minus. When solving and taking a square root, it could be plus or minus. So plus or minus root 32, basically. Okay, so now let's go to this one, number 21. So it says, Tim takes the stairs up to his office. He enters the ground floor of the building and climbs 12 steps to reach the first floor. He climbs a total of 24 steps to reach the second floor and 36 steps to reach the third floor. How many steps will Tim climb to reach the office on the 16th floor? So first of all, you have to think about with these story problems, is it just asking us for the 16th term or the sum of all of these things? So it wants to know how many steps he will climb total. So if you think about it, that's going to be a sum. Now it kind of helps to draw our picture. So on the first climb, he did 12 steps. The next one he did 24. The next one 36. So there's a pattern here, each floor. So you could say, well, we're going to be summing. So we're going to find the sum. Now it wants to know the 16th floor. So we're going to be summing up the first through 16th floor. And then our formula goes here. Is it arithmetic or geometric? Well, this minus this minus this, is it the same amount? Are we adding, or is it this divided by this equal to this divided by this? So I noticed there's actually a common difference of 12, making it arithmetic. So your formula for arithmetic is this. So a sub 1 was 12 plus n minus 1. Our common difference was 12. Multiply 12 in. So with this one, our 12s went away, so we have a 12n. You would type it into your calculator, and you get 192 steps total. That was summing, because we wanted to know how many total steps he had to take to get up to the top floor. Number 22, it says, find the 8th term of the geometric sequence. So a sub n is equal to a sub 1 times by r raised to the n minus 1. We're going to do a sub 8. Our a sub 1 was 4. Our common ratio, this divided by this, is 3. And then 8 minus 1. I mean, a lot of this is repetitive, and it's just to get you re-looking at things over and over again to make sure you're good to go. Okay, write an arithmetic series in summation notation, then find the sum. This is like what you might see on a test. You say it wants it in summation notation. So we're finding the sum, obviously with these plus signs. Now we put our explicit formula. There's a common difference. This minus this is 6. This minus this is 6. So a sub n is equal to a sub 1 plus n minus 1 times d. So our a sub 1 is 5 plus n minus 1 times by 6. Take 6 in. We have 5 plus 6n minus 6. So our formula in here is 6n and then minus 1. 5 minus 6. 6n minus 1. Now we're summing up 1. Here's a sub 1, 2, 3. We don't know what a sub n is. So 1 through, we don't know. We need to know that to actually be able to find the sum. So we've got to push pause on that and come back to it. So now remember, you can go back and plug it in to your formula. Oops, trying to erase here. So we know that this formula right here, the a sub n is equal to 6n minus 1, allows us to find any term in the sequence. Here's a sub n. 371 is equal to 6n minus 1. And now solve for n. This one doesn't take a logarithm because it's arithmetic. Add 1. 372 equals 6n. Divide by 6. So it comes out that that is actually 62. So now you would type that into your calculator and you get 34968. There's our sum. So with this one, you do that same thing. You would say, okay, I'm finding the sum of our formula here is this minus this is -8. This minus this is -8. So it's arithmetic. So a sub n is equal to a sub 1 plus n minus 1 times by d. So a sub n is equal to a sub 1 is 212 plus n minus 1 times by -8. Distribute -8 in. So we would have a sub n is equal to 212 minus 8n plus 8. So our explicit formula is -8n and then plus 220. And then we're summing up 1, a sub 1 through 2, 3, we don't know again. So we've got to hurry and plug that in. So we have a sub n is equal to -8n plus 220. So we know a sub n is -20 is equal to -8n plus 220, and then solve for n. So I'm going to subtract 220, subtract 220. We have -240 is equal to -8n, divide by -8. So n is equal to 30. So we're summing up 1 through 30 terms, and our sum comes out to be, we would type it into our calculator, 2880. Okay, it says find the sum of the geometric series. So, once again, we'd say we're finding the sum. It's finite. We know the start and end. Our formula goes here. It's geometric. So a sub n is equal to a sub 1 times by r raised to the n minus 1. This divided by this is 1/2. This divided by this is 1/2. So our a sub 1 is 1/6 times by 1/2 raised to the n minus 1. And then we're summing up 1 through, we don't know. So with this one, it's honestly easier just to take n times by 1/2 until you get to here and then count. So the number, instead of doing logarithms, so it's 7. Or you could do the logarithm thing for sure. That would all work. You would be going, okay, 1/384 is equal to a sub 1 is 1/6 times by 1/2 raised to the n minus 1. So then you divide by 6, then you'd log base 1/2 both sides, and so on. Okay. So then you would type it into your calculator, and it comes out to be a decimal point, 33072916667, some huge decimal. All right, looking at this one, to find the sum, you'd say, well, it's infinite, it's geometric. Then we can find the sum if our r is less than 1. 0.4 is less than 1, so we can find the sum. Unfortunately, we have to remember the formula a sub 1 over 1 minus r if it's infinite and geometric, and we can find a sum. A sub 1 times by r raised to the n minus 1. A sub 1 is 3. 1 minus r is 0.4. Use parentheses. So if you type it into your calculator, it will come out to be, the sum actually adds up to be 5. And that brings me to our last question. Well, not quite. A guitar making company produced 60 guitars this month. So write out a picture if you need to. So this month. The company plans to increase production by 8% each month for the next 9 months. So for the next 9 months. So starting here, the next 9 months, not a total of 9 months, but the next 9 months. So 1, 2, 3, 4, 5, and so on. 6, 7, 8, 9 months. So the next 9 months, that was tricky. A lot of people mess up on that. It said, if it said how much total over after 9 months, then we would just use 9. But right here it says starting with 60, the company plans to increase production by 8% each month for the next 9 months. Next 9 months. Okay, cool. So now it's increasing by 8%. So that means we are going to be getting back 100% of that plus an additional 8%, which is 108%. Otherwise, we are not getting back the full 60. And we are. And then an 8 more. So that would be as a decimal 1.08. So our R, what we're timesing by, is 1.08. From this month, we'll times by 1.08 and get this. Times that by 1.08. We don't want to do it the long way though. So we're going to write it out. We're finding the sum of 1 through 10, because how many total are we summing up? Well, we called this 1 through 9. That's a total of 10. And then right here's our formula. So our a sub 1 is 60 times by 1.08 raised to the n minus 1. And then you could type it into your calculator. There are times, though, when you don't double dip. It's all in the wording of the story problem. So there are times when this would count as 1. But because of the word the next 9 months, you type it into your calculator and you get 869 guitars. Total, that's how many they'll produce in the next 9 months if they started with 60. Write a polynomial in standard form. So you are going to be asked to, you'll have to know Pascal's triangle, and on the test you'll be asked to write a polynomial in standard form that looks something like this, for example, x plus 2 to the 5th. So remember, you would go down on Pascal's triangle. This is degree 0, 1, 2, 3, 4. So I got to keep going. So right here, we would use these coefficients, and then we would take our front thing, which is x. X to the 5th, x to the 4th, x cubed, x squared, x to the 1st, x to the 0. And we would take our back thing, which is positive 2, 2 to the 0, use parentheses, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, and then you would just simplify it. So we have a 1, a 2 to the 0, which is 1. 1 times x to the 5th is x to the 5th. We have a 5 times 2 to the 1st, which is 10, plus 10x to the 4th. Then we have a 2 squared, which is 4 times 10 is 40, x cubed. We have an 8 times 10, which is 80, x squared. We have a 16 times a 5, which it happens to be 80 again. And then we have 2 to the 5th, which is 32. So just remember how to expand, and then you will be given one where you're asked to expand a little bit larger one. Not too bad, though. Something like 3x minus 1 to the 4th or 5th. And then you would go through that same process. So that's the end of the video. If you need to remember how to do this stuff, go watch the video before this, which was 11-4. Good luck.